Okay, the next big issue to cover, the next fossil fuel to deal with is natural gas. Sometimes you'll hear it called other things, but natural gas really is a term that describes lots of different of the ANEs, A-N-E. And of course, as the book says, most of the natural gas that we see is methane, CH4. But 5 to 20% are the other ANEs, like propane, ethane. You get the idea. Natural gas is found, as we saw from that previous diagram, usually sitting on top of oil drilling wells. And oftentimes, before we realized some of the advantages of natural gas, or really, I think the better way to say it is, before we were drilling solely for natural gas, we would just burn off the natural gas that was on top of oil wells. If you were drilling for oil, that's what you were looking for, that's what you were interested in, you didn't care about the natural gas. Today we know that natural gas has very, very important applications, and so now we're trying to capture all of that natural gas. There are places where a natural gas reserve is the only source. There's no oil there, but just natural gas. However, most of our big natural gas areas are also where the oil is. Natural gas is used primarily in transportation and electricity. I think I mentioned to you before that municipalities, state departments, even in the military, anybody that purchases lots of vehicles is very tempted to purchase vehicles that run on natural gas, because natural gas is cheaper, it runs way cleaner. And especially if you're a city, you have to worry about the quality of the air in your city. You have all of these vehicles concentrated in such a small area. You want to decrease what comes out of the tailpipe. So burning natural gas instead of gasoline is a good way to go. I also mentioned that St. Johns County actually runs its school buses on natural gas. The nice part about this is when the natural gas tank runs out, they just go back to their fill-up facility. In a city, there's probably 2 or 3 of them all around the place. Fill up their natural gas tank again, and away they go. Up north, they use natural gas for electricity. And in addition to that, most of the homes have an additional pipe going into their house that carries natural gas to their home. And there are some real advantages to having appliances that operate on natural gas. For instance, stoves and ovens give a very nice, even, direct heat to your saucepans. And not only that, but it seems to get things hotter faster. After all, you actually have your pot or your pan on flame. You're not trying to heat up coils using electricity. So people really kind of like the idea of natural gas for their appliances. In addition to stoves and ovens up north, frequently you'll find your water heater connected to a gas line, so you can use natural gas to heat your water. And even furnaces are connected to the natural gas line. All of these lines are fed into the homes from some major natural gas facility that will be in your town, and provides people with all of the power that they need to heat things up. Another form of natural gas that we see very frequently, and you're used to seeing it here in Florida, is LPG. That stands for, write it down, liquefied petroleum gas. Now this is the stuff that's in the propane tank that you go to the store and buy and connect to your gas grill. Liquefied petroleum gas. Now that makes the gas a little bit easier to transport. you can imagine the infrastructure required to run these gas lines. Piping all throughout a town, a city, places like that. And anywhere along the line, if a pipe breaks, then there's a release of the natural gas. It's odorless and colorless. And so you run into some real problems. For instance, if there's an earthquake and a natural gas pipeline snaps down under a road, you can end up with an explosion because that gas builds up and then gets ignited somehow. Big problems. So the liquefied petroleum gas is a way sort of around that, because now you can transport your natural gas in containers. And you don't have to worry about having it connected in pipelines. That makes LPG a little bit better. 24% of our energy here in the United States is natural gas or LPG. We have 200 years worth of natural gas here in the United States, so it is an attractive alternative to burning coal or burning gasoline in cars. Also, it's known to burn cleaner. What that means is less CO2 emissions, and also there's no particulates left behind like there is when you burn coal. There's none of the impurities, the mercury, the arsenic, the lead, those other impurities that are in coal are not found in natural gas. Lots of advantages then to natural gas. But here's what I really wanted to focus on. This debate is one that's raging right now, and it's the debate about something called fracking. Sometimes you hear it called hydraulic fracking. It's a controversial new way that companies are accessing natural gas. And essentially, here's how it works. They drill their pipe and they pump in a whole bunch of water, air, even sand. They pump these things down into the natural gas well to force or to push the natural gas up and out. You'll recall from our original story about natural gas that companies have used these things called thumper trucks as well. All of this idea here is to break up the rock that the natural gas is in. See, natural gas deposits aren't found in a nice cave sort of completely surrounded like it is with oil. Instead, there's little pockets of gas all throughout rock formations. So in order to get to that natural gas, you have to shake up or break the rock in order to access the natural gas and get it up to the surface. This process is called fracking. One of the big issues when it comes to fracking is that in order to speed up that process, companies aren't just pumping in water and sand, but they're also using some really nasty chemicals, dangerous carcinogens chemicals in this mix of stuff that they pump down in there to break up the rock and free up the natural gas. The reason that this is particularly controversial is because these chemicals are later found in the aquifer, in the drinking water, in even the surface waters in the areas around where fracking happens. So you can imagine communities are not all that interested in having fracking happen in their area. Now, there's a double-edged sword to this, because if a company has found that natural gas reserves are on your land, they will pay you to go and frack on your land. So you stand to make money if you let a company frack. So that's the big issue. It seems to be polluting. This is such a new thing that we don't have all of the studies in. You know, there are just as many scientists for the natural gas companies claiming that fracking is not dangerous. One of the big things from a legislative point of view that's happening that's a problem for fracking is that in 2005, George W. Bush signed into law a limitation to the Clean Water Act. And that limitation was that fracking companies did not have to report what they're pumping down into the rock formation to break it up. So it is officially unknown what sort of nasty chemicals are actually being used, and these companies are free to use them. Then when a community discovers problems with their drinking water, you know, the natural gas companies say, look, that would have happened anyway. It had nothing to do with us doing our fracking. It's been so bad that people have reported actually being able to light on fire the water that came out of their faucet. There's been reports of farmland where all of the cattle have died from drinking from a lake or a pond that's had these chemicals come up to the surface because of fracking. So it's a big political football and very controversial because not all the data's in yet. Tomorrow in class I want you to ask me to show you this other YouTube that I have that's a little bit too long to bother with in this video. Here are the advantages and disadvantages of natural gas. Now remember, you should be building this type of table in your head. It contains fewer impurities and it emits not nearly as much carbon dioxide as when you burn coal. But when you dig for natural gas, when you mine for it, some of course is going to escape. There's just no getting around that. You can't control all of the gas that's coming out. And methane is a very, very powerful greenhouse gas. In fact, it's way more powerful than CO2 is. Here are some other fossil fuels of note to talk about. I told you I'd mention these. This is on page 330 in your book. There is a lot of work being done about trying to get the oil out of rock formations and get them out of these things that are called tar sands. Just like the name indicates, this is thick, sticky. You know, tar is almost all oil, but it's thicker and heavier. So these chemicals are petroleum. They can be separated and then refined and turned into gasoline. The problem is tremendous amounts of energy are required in order to separate the oil, for instance, from the oil shale. Here's a nice picture. This large rock produces about this much oil. And you can imagine the heat that's required to process this rock and squeeze the drops of oil out of it that's there. And the same thing is true with bitumen. It's called tar or pitch. It's a thick, heavy, oil-laden substance, but you've got to separate the oil out. It takes tremendous amounts of energy. And these types of processes release higher amounts of carbon dioxide as well. The last part before we get to nuclear energy is just the recognition about finite resources. You can see here, one of the problems that worries us a great deal in the environmental community is that we continue to get better and better at providing energy to customers, which means fuel is getting cheaper and cheaper, at least when it comes to, for instance, your electricity. We are getting extremely efficient at delivering energy use per dollar here, and it continues to decline. You know, which means there's no disincentive for you to use up a whole lot of energy. Now we are seeing the price of gas go up, but that's not, you know, this graph here is about dollars of GDP. It's not about the actual cost. Yes, the cost of a gallon of gas is way up. But as I've mentioned to you before, what's the number that's going to make you change your energy consuming ways? And the same thing could be asked of electricity. You're not paying an electric bill now, your parents are, but someday you'll be paying that electric bill and you will care how much the furnace runs, how many, how long or short your showers are, because that will directly affect your electric bill. Per capita use, per person usage of energy hasn't changed all that much since about 1980, but our energy use in the United States does continue to rise because there's more per capitas. There's more people. Now our growth rate has slowed down, so the growth of our actual usage will start to taper off as well. Per capita wise, this will continue to go up as more and more people have cell phones that they have to charge. They'll buy these Kindles, iPads, all these other devices that are so convenient and so great to use. They've got to be charged. They've got to be plugged in. The last thing to bring up is this thing called a Hubbert curve. And this guy is a geophysicist. And the point here to tell you about is just his idea, his recognition is that when you've got a finite resource, like oil for instance, this graph shows you oil. When you have a finite substance, like oil, you are going to drill for it, and you are going to get very, very good at it, and you're going to keep getting that oil out of the ground. You're going to keep getting it, and you're going to hit something somewhere along the line that's a peak. In other words, you're at the top level of production that can happen. All the oil per day that can be pumped is being pumped. A lot of experts, even those that are not environmentally savvy, are saying that they think that we are at this top right about now. This is called peak oil. But the important thing to notice about the Hubbert curve is look at how quickly oil production will decline once we hit peak. Now scientists, some scientists are saying we're not going to worry about this because we'll run out of oil, we'll figure out what the next thing is, whatever it might be. In the book they said one scientist made the comment, we didn't come out of the Stone Age because we ran out of rocks, because we ran out of stones. We moved on because we found a better thing to use. And so many scientists are saying we'll find that better thing, that thing that's better than oil. But others are very concerned that this decline can happen so rapidly that we'll be caught unprepared and unaware. And so that our fossil fuel consumption will need to either be drastically curtailed or completely replaced. Can you say horse and buggy? All right, the last thing in chapter 12 is nuclear energy, and that's its own separate video. So I'm going to sign off for now. Remember, don't forget to remind me to show you that YouTube video. Kids seem to really like it.